Yes, Aditya. In today's class, we'll learn about method of multipliers. Method of multipliers. Last class we have seen for the grouping. We were finding the two solution with the help of the grouping one. Now in some problems, grouping is not possible. In that case, we'll move for multipliers. First, you're going to write that auxiliary equation. Your AE, what is your AE is going to be? Dx divided by capital P, it's equals to dy by q, it's equals to dz by r. What is it your equation form? It's going to be, what is your Lagrangian form? Yes, Aditya. Aditya, I need a response, Aditya. Yes, what
Yes,
is the
ma'am.
form? Actual form here? It has to be in
D
the form of
D of
P
x plus
suffix
Q of
P
R.
plus Q
D of
suffix
Q.
Q. It's equals to R. First, you're going to write that auxiliary equation, that is dx by P is equals to dy by Q is equals to dz by R. After that, you're going to, for the multipliers, that is going to be in the form of L1 into dx. Why L1? Directly L1 will take. L dx plus m dy plus n dz divided by L p plus mq plus n r. You are going to choose your L m n in such a way this term, the denominator term, has to become 0. You're going to select this L m n in such a way this part has to become its equals to 0. Something by 0 is equals to infinity, but here we are not going to write it's equals to infinity, because according to the theory only you have to make your denominator part is equals to 0. Then you are going to equate it's equals to 0. You are going to choose L m n in such a way that it should be in such a way so that your LP plus MQ plus NR should become its equals to 0. And then it will become L dx plus mdy plus ndz divided by 0. It's equals to 0. This 0 will be multiplied over here. You're not going to write it's equals to infinity. You're going to make your ldx plus mdy plus ndz, it's equals to 0. Then integrating on both the sides. Integrating on both the sides. That is your ldx, sorry, integrating ldx plus integrating mdy plus integrating ndz, it's equals to some arbitrary constant. This is one type of a solution. Yes, Aditya, any doubt over here? The method is clear.
Yes, ma'am.
So shall we see the problem?
Yes, ma'am.
Wait, let me select the problem. Done. Yes, the problem. Write down the problem, Aditya. Solve solve y minus z into p, then plus x minus y into q, it's equals to z minus x. Yes, it is in the form of your p suffix p plus q suffix q is equals to r. It is in the form of p suffix p plus q suffix q, it's equals to r. Here p is equals to y minus z, and your q is equals to x minus y, and r is equals to z minus x. First, we'll write auxiliary equation. Your a is equals to dx by p, it's equals to dy by q, it's equals to dz by r. Substitute the values. Dx divided by y minus z, it's equals to dy by x minus y is equals to dz by z minus x. Now see Aditya, it's a possible to get the solution with the grouping. If you're going to solve first two and first and last, or middle of second term and third term, it's a possible to get our solution there. If we'll go with the grouping method, with the previous method,
No,
it's a
ma'am.
possible?
Because
No.
no,
With the
because
grouping,
no.
we are not going to get a solution. So what we will do, we will go for the multipliers. What is that multipliers? Formula is what? LDX. That is your LDX plus MDY plus NDZ divided by LP plus MQ plus NR, it's equals to 0. First, you substitute your PQR values, so that for you it will be easy to substitute the values of L, M and N. Your L, dx plus MDY plus NDZ divided by L into P is equals to y minus z, then plus m into x minus y, then plus n into z minus x. What happened? It's equals to 0. Now see what values you're going to substitute here. L, m, n, y minus z is here. So if I'm going to substitute L is equals to 1, M is equals to 1, N is equals to 1. Easily this term will become its equals to 0. Yes or no? Y,
No, can
and
you just
here y
repeat?
will get cancelled. Z, and here z will
No,
get cancelled. X and minus x will get cancelled. So one solution, I can substitute L, M, and we need two solutions here for writing the general solution. And so therefore we will take, let L is equals to 1, M is equals to 1, and your N is equals to 1. It is equals to dx plus dy plus ndz divided by y minus z, then plus x minus y, then plus z minus x. It's equals to 0. See, plus I will do the cancellation with different color. Here your y and minus y will get cancelled. Minus z plus z will get cancelled. Then plus x minus x will get cancelled. You are left with dx plus dy plus dz x zero. It's equals to 0. Now cross multiply dx plus dy plus dz, it's equals to 0. Now integrating on both the sides. Integrating on both the sides. Dx plus dy plus into dz is equals to some arbitrary constant c1. It's equals to x plus y plus z. It's equals to c1. Your constant integration is equals to respective the term only will come. The first one, it's a 1 into dx. So integration of a constant is equals to x. dy, that constant. Then a constant integration of 1 with respect to y, it's a y. Then with respect to z, it's a z. So c1. One part of a solution is over. Now for the second time, what you're going to choose your LMN so that it's going to be 0. See again, what we need as an 2 more solution for writing the general solution. So 1 is over. So once again I will write that one. Your
2.
LDX plus MDY plus NDZ divided by your L into Y was Y minus Z, then plus M into X minus Y, then plus N into Z minus X. It's equals to 0. Now you choose some other different one. It can be a function, it can be a constant also. It's not a compulsory that you have to assign as a constant number only. You can take your L, M, N values as a function values also for making this term is equals to 0. So with the constant, we got one solution. Now see with the functions, what functions you are going to substitute your L, M, N so that this term should become its equals to 0.
A or B or some
What is
constant
your
A
L
or
is
B.
going to be? What you are going to take L is equals to?
We can take it as A itself.
Why A you will go constant? That is a constant. With a how it's going to be help
Yes.
out? Now go with the functions I'm saying. I have given you the hint also. If you will take L is equals to X and your M is equals to M is equals to Z, okay, and here is another. So M is equals to Z and N is equals to Y. With this you see whether it's going to be 0 or not. Here this denominator part X into dx plus z into dy, then plus y into dz divided by your x into y minus z, then plus z into x minus y plus y into z minus x. It's equals to 0. Whether it's becoming 0 or not, x into dx, then plus z into dy plus y into dz divided by x y minus x z plus zx minus y into z plus y into z minus x into z becoming 0 or not? y, actually we have written the functions right or not? X minus y,
Minus xy.
it's becoming 0
Last
na.
is minus xy.
See this
Yeah.
x y, and where is one more xy? This and this will get cancelled. Becoming 0 or not? I'm not saying as I'm not able to see one more xy over here. Oh, here I have written mistake. This term as this is equals to x y. So this is got cancelled. Then this and this will get cancelled. This and this will get cancelled. Yes, with this one it's becoming 0. So your x into dx plus z into dy plus y into dz, it's equals to 0. Integrating on both the sides. X into dx plus z into dy plus y into dz, it's equals to some arbitrary constant c2. Arhan, क्या हो रहा? Then integration of this one is equals to x square by 2, then plus z is there, and here your integration is with respect to y is there. So this will be treated as a constant. So it's going to be uh, z into y, then plus. Here also you see y is there and integration with respect to z is there. So y will be treated as a constant. So it's going to be y into z. It's equals to c2. It's going to be 2 x square by 2 plus 2 z y. It's equals to your c2, where your general solution is equals to 5 of c1 comma c2. It's equals to 0. It's equals to 5 of what we got first one, it's x plus y plus z, no? X plus y plus z. Then next is your x square by 2 plus 2y z. It's equals to 0. Yes, Aditya, any doubt over here? It's a clear.
No, it's clear.
It's clear. So you got your multipliers also.